Chapter 2, Section 3, Relate Fractions, Decimals, and Percents. This is the third lesson I have built on our Hurricane Ida Monday, day off from school. So we'll see how much more I can get done today. I'm hoping to knock out this entire chapter. Students will relate fractions, decimals, and percent. That's your content objective, and your suggested pacing says this is going to take us 135 minutes. So this is probably going to be a 2-day lesson. Let's get started. A basketball team made 12 out of 15 free throw attempts in the first game, 9 out of 16 in the second game, and 7 out of 12 in the third game. Ratios are sometimes used to compare, but comparing different ratios can be difficult when they do not have the same denominator. Sometimes expressing numerical information in a different form helps to gain a better understanding of the information. And that's the kind of stuff we're talking about here, comparing fractions, decimals, and percents. How could the coach determine if the team improved their free throw accuracy? Well, what I would suggest is take each of those ratios and divide the numerator by the denominator and compare the decimal values that you get for each one. Holy cow, this one has 8 slides in resource number 2. Why is it helpful to write a ratio as a percent? Well, what I just said, if you don't have a common denominator, it could easily allow you to easily compare 2 different sets of numbers. So how are we going to do this? 4 different groups of students were asked about their favorite sport. The table shows the number of students from each group that chose soccer as their favorite sport. What are some strategies you could use to compare these 4 groups? You could work them to where they have a common denominator, such as 100, I think would be the best common denominator to work with. Or you could divide them out to where they all are a decimal value, or you could then multiply that decimal value to find a percent of each one. Let's see what the textbook suggests to do. The grid has 100 squares. Woo! Alright, forget that. Let's start up at the top. Represent the students from Group A that chose soccer using a 10 by 10 grid. Now in Group A you have 3 out of 20, and it says, well, we got to actually do some math here, don't we? So let's pause the recording while I get some screenshots and we will work through that. Now we are working with a 10 by 10 grid, which means we need to get our second part of our ratio, which is 20, to be equal to 100. That means we have to ask ourselves 20 times what number equals 100. And of course that's going to be 5. If I do it on the bottom, I have to do it on the top, which means I'm going to have 15 on the top. So I'm going to have 15% of the grid. Going back over here, we're going to have to take and shade in 15%. That means we're going to take 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And let's check our answer. Our answer checked beautifully. So that is a visual representation of the 3 out of 20. Now it's going to be pretty cumbersome to have to do that for all of them, but let's see what the next step says to do. It looks like they want us to do the same thing for Group B. So now in Group B, it starts out with being, let me get my marker the right way here, 3 out of 25. I'm going to have to once again get that denominator to equal to 20. My scratch work is going to say 3/25 times what number equals something over 100. Of course that's 20 times 5 times 4. If I do it on the bottom, I have to do it on the top, which is going to give me 12% of the number. So for that, we're going to come back over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and check our answer. That one checked as well. Next we're going to do, let me guess, grid C. So let's do that one as well. Now wait, grid C is actually, yep, it's 1 out of 20. So we're going to set the 1 out of 20. I was thinking it was 1 out of 100. So I got 1 out of 20 times, or excuse me, is equal to over 100 here. So I got to do 1 out of 20 times something over something equals something over 100. That's going to be 5, because 20 times 5 is 100. 1 times 5 is 5. So we have 5 out of 100, also known as 5%. 1, 2, 3, 4, 5. Check our answer. That one checked. And then the last one's going to be super easy, because the last one, group D, is out of 100. We don't even have to do any math. All we have to do is shade in 9 spots on that one, check our answer, and it is correct as so. Now when we move forward from there, you can compare each one of these grids. The first one is going to be how much? 15%. The next one, 12%. The next one was 5%, yep, and the last one was 9%. And when we check our answers, all of that checked beautifully there. I'm disappointed it didn't go ding. All right, now compare the percents for each group. Which group had the highest percentage of students that chose soccer? Well, that was going to be Group A, because if you look at the chart, Group A had the most shading, the red one up there, at 15%. Check our answer. It did check correct. So, why is it helpful to write a ratio as a percent? You pause the recording and type in an answer, and then we'll see what the textbook said. Our textbook said when you have ratios with different denominators, you can compare them more easily as percents, because percents are given as parts per 100. Makes sense to me. By definition, a percent is a ratio that compares some number to 100. We've already talked about that. The percent 35% compares 35 to 100, and you could write that as a ratio as maybe 3:100. Fraction form is going to be 35 over 100. I think I said 3 colon, it should be 35 colon. Both of those represent 35 hundredths. You can use the definition of a percent, equivalent ratios, and place value reasoning to write percents both as fractions and decimals. So let's take and see how to write 35% as a fraction and as a decimal. As a fraction, 35% is going to be 35 over 100. Of course, you would need to simplify that. The largest number to divide into 35 and 100 is 5, so that's going to give us 7 over 20. So 35% as a fraction is 35 hundredths. In simplest forms, it's going to be 7 twentieths. But what about as a decimal? To write 35 hundredths as a decimal, write what it says. It says 35 hundredths. So what do we have right here? 35 hundredths. Boom, done. You didn't have to do any long division, didn't have to do any funky math. All you had to do is read what this says. 35 over 100, 35 hundredths, and then know how to write 35 hundredths as a decimal. Now you could write 35 over 100 or 7 twentieths to represent a fractional form of 35%. Are there different ways that you could write the decimal form of 35%? Not really. I mean, you could put zeros on both ends, but they wouldn't really do anything. So you could do like 35.0000%, but I mean, why? So no, 35%, that's really going to be pretty much your only option for writing that one. In a recent survey, about 95% of smartphone users claim to send text messages. What fraction of smartphone users is this? Write the decimal. What decimal is this? Think about this. What is the first step in writing a percent as a fraction? Well, a percent is a ratio of some number to 100. So all we have to do is take and drop the percent sign and place the 95 over 100. Now, that is not in simplest terms. You always have to be able to simplify your fractions. But the simplest terms, we're going to be finding that equivalent ratio. Let's take and do a screenshot. So in this problem, I've got 95 over 100. I need to simplify it. The largest number that's going to divide into both of those is 5. 5 goes into 95 19 times. 5 goes into 100 20 times. So in simplest terms, our equivalent ratio is going to be, let's put it in here, create our fraction. We'll have 19 over 20, except, check our answer. That one checked good. Now, 95% is a decimal. Well, 95 over 100 you read as 95 hundredths. That is 0.95 or 0 and 95 hundredths. Tenths place, hundredths place. Check your answer. It checked again. So 19 twentieths and 0.95 smartphone users claim to send text messages. Both of these values are, of course, equivalent to the 95% we started with. Now it's going to be your turn. I want you to pause the video and solve this problem while I go grab some dark chocolate M&Ms. Did you finish it? Let's see what I do here. During his workout, Alan spent 28% of his time on a treadmill. What fraction of the workout was this? And what decimal is this? Well, for starters, I'm going to put in my 28% as being 28 over 100. But that problem is not in simplest form. So I'm going to have to divide top and bottom by the largest number that will go into both, and that's going to be 4. 4 goes into 100 25 times, and 4 goes into 28. Let's see here, that's going to be 5, 6, 7 times. So our simplest term answer should be 7 over 25, which I believe is what they're going to look for here. And the decimal is going to be even easier. Read your number, 28 hundredths, 0 and 28 hundredths. Let's go back to our website and put those two numbers in. First one's asking us for a fraction. Let's see if they're going to simplest terms it. 7 over 28. Accept that. And then 0.28. Check our answers. I wonder if they wanted that one as a improper, or to me as a not simplified version. So let's take and find out. We're going to go back in here and let's take and do. Oh, I see what I did wrong. I said 28, not 25. So let me go over here, 25, except, now let's check my answer again. That was my mistake. I put in the wrong number in the denominator. Now we're going to learn to relate fractions to percents and decimals. You can see here we've got the fraction 3/20 given to us, and we want to understand the equivalent ratios, the definition of percent and place value reasoning to write 3 over 20 as a percent and a decimal. So first, when writing a fraction as a percent, why would you find an equivalent ratio with a denominator of 100? Well, because a percent is a ratio between some number and 100. And you can see that's exactly what they did here. Now, they didn't give very good supporting work, though, so let me take and do that. So let's take a look at what they did to come up with these numbers. Now, they had, give me my cursor over here, they had 3 over 20. And they needed to get it to equal to something over 100. So they said 20 times what number is 100? 5. If they do it on the bottom, they have to do it on the top, and that gave them 15 over 100, and 15 over 100 is, of course, going to equal to 15%. So that's where that number ended up coming from. Now, whoop, that's not what we were supposed to bring up. Let's try this again. Now, to do it as a decimal, all you had to do is read that 15 hundredths. 15 over 100 is 15 hundredths, and rewrite it as 0.15 or 0 and 15 hundredths. Easy math. Anybody can do this stuff. Now consider the fraction 9 over 15. How can you write this fraction as a percent? Knowing that there is no whole number by which you can multiply 15 to get 100. Let's take a watch of this animation and learn how to write 9 over 15 as a percent.
To write 9/15 as a percent, first simplify the fraction by dividing the numerator and denominator by their greatest common factor, 3. 9 divided by 3 is 3. 15 divided by 3 is 5. 9/15 equals 3/5. Then write an equivalent ratio with 100 as the denominator. Since 5 times 20 equals 100, multiply 3 by 20. 3 times 20 equals 60. 9/15 written as a percent is 60%.
Did that look familiar to you? It should, because that's really similar to what we did in the last chapter when we were dealing with rates and ratios. A classmate claims that you can always write a fraction as a decimal by dividing the numerator by the denominator. Is this a valid method? Why or why not? The answer is absolutely. You can always divide the numerator by the denominator, and when you do, you're going to get the decimal version of the answer. Sometimes, though, it's easier to use multiplication like we've been doing in this lesson than it is to use long division, because I know it. Y'all don't like long division, guys. A different classmate wrote the decimal form of 9/15 as 0.6. Another classmate wrote it as 0.60. Who is correct and why? Technically, they're both correct. However, I would say this one here is more correct, the 0.6 or 0 6/10, because this 0 on the end from the 0.60, it has no value. It does nothing but hang out there and get in the way. Now that's going to be it for part 1 of this video. We're going to get it ready to upload, and then I will come back and work on part 2 so you can learn the rest of our section on relate fractions, decimals, and percents.